Today we'll turn your Firestore database into a full-text search engine using Algolia.
It's pointing at something. Look, it's the rest of them!
It's one of my all-time favorite APIs, and I use it on Fireship.io to power content discovery features like instant search. What you'll build today is a pipeline with Firebase Cloud Functions that automatically indexes your Firestore data in Algolia. And then we'll look at multiple implementations to consume that data from a customer-facing app. If you're new here, like and subscribe, and check out the full source code at Fireship.io. So let's start by answering the question of when would you want to use a service like Algolia? And keep in mind, this video is not sponsored, so these are my own personal opinions.
Yeah, well, that's just like your opinion, man.
NoSQL databases like Firestore are designed primarily for fast reads and to scale seamlessly, but they can be relatively limited on the types of queries you can make, especially if you need to search across the entire text of a document, or if you need to filter by multiple properties simultaneously and keep track of counts of different properties. Algolia solves all of these problems for you and more. It's really an ideal solution if you have something like Amazon, where you have millions of products and you need to sort these products and filter and search them in many complex ways. Now, Algolia starts off with a free tier, but one of the biggest complaints you might hear is that it's expensive. And I do think that's a very valid complaint, especially if you have millions of records. It jumps from free to $29 per month up to $500 per month. But as you'll see in this video, this is kind of a situation where you get what you pay for. The first thing you'll want to do is sign up for an Algolia account, and then it will walk you through the process of creating an index. I'll go ahead and create a new index called Customers, and this will basically be a mirror of our Firestore data, minus any personally identifiable information. Things like email addresses and phone numbers are not something that you want to keep in the index. You should keep in mind that all this data will be exposed client-side, so you want to leave out any information that would be considered sensitive. So now that we have this index set up, we have a whole bunch of different ways to customize it. I'll leave the customization part up to you, but just know that there's a whole bunch of cool things you can do, like set the searchable attributes, tweak the ranking and sorting algorithms, set up typo tolerance, stop words, and word proximity, and a whole bunch of other stuff. And you could even generate your own UI demo based on your own underlying data. And that means you can get a solid mockup of your search UI before you write any front-end code. So now that we have this index created, we need a way to dynamically add data to it. And we want to add data to the index every time a new Firestore document is created. As you can see here, I have Algolia on the left and Firestore on the right. When new documents are added to the database, they will automatically be updated in the index. Indexing operations will always happen on the back end, which we'll do with Node.js and Firebase Cloud Functions. We'll start from an empty working directory and then run Firebase init functions. I'll be using JavaScript for this demo, but feel free to use TypeScript if you prefer. That command will give us a functions directory, and you can ignore all of the other directories that you see on my screen for now. But you can see all of these framework-specific front-end integrations in the full source code. From there, we'll cd into the functions directory and install Algolia Search. This is an API client for Node, and it's going to require our API keys, which we can retrieve from the Algolia dashboard. You'll need your application ID as well as your admin API key. And then we have this big long command to save the API keys in the functions environment. And the reason you want to have these as environment variables is if you ever have to change the API key, then you can simply reset it in the environment without having to redeploy your cloud functions. At this point, we can open up the index.js file and we'll start writing some code. We'll go ahead and import the Algolia search client, and then we'll make a reference to the app ID and the admin key that we have in the functions environment. We'll pass those values to Algolia search, and then we'll initialize the index by calling init index with the name of our index, which in this case is customers. And now we can reference this index in any one of our cloud functions. So we'll go ahead and start by creating a new Firestore function called add-to-index, which makes a reference to a Firestore document. Whenever a new document is created in the customer's collection, it will run the code inside of this callback. The snapshot contains the newly created data from the Firestore document. That's the data that we want to duplicate in Algolia, minus any personally identifiable information. Now we can identify a record in Algolia with its object ID. So the object ID will be equal to the Firestore document ID, and that's how we kind of connect the two objects together on both platforms. Then the final step is to return a promise from the function, which we'll do with index add object with a JavaScript object containing the data and object ID. And that's all there is to it. Now every new customer document in Firestore will be duplicated in the Algolia index. But this function will only run on create, and it's possible that the data might change or might be removed in the future. So we'll set up a couple of additional cloud functions here to handle those requirements. We'll create a second Cloud function called updateIndex that runs whenever the Firestore document is updated. This function is almost identical to the last one with just some minor differences. Instead of having the document snapshot, we have a change object, which has the Firestore document before the change and after the change. We're only concerned about the changes afterwards because that's what we want to update in Algolia. And we'll do that by calling indexSaveObject to update a single object with this new data. And lastly, we'll create one additional function called deleteFromIndex that will run when a document is deleted from Firestore. And this one is the easiest of all. We simply call indexDeleteObject and pass it the Firestore document ID. And again, that's why it's important that your Algolia object ID matches the Firestore document ID. Now we can deploy our three functions by running Firebase deploy only functions from the command line, and then you should see your functions in the Firebase console. Now at this point we could create some dummy data manually in the Firebase console, but I want to show you a little trick to quickly seed the database with some fake dummy data. We can install Faker.js in the Cloud Functions environment, which allows us to generate a massive amount of fake random data. From there, I've created a new file called seed.js in the functions directory, and I'm going to import Firebase admin and then call admin initialize app. Now, this isn't actually a Cloud function, it's just a node script that will run from the command line in just a second here. We'll go ahead and import Faker, and then we'll make a reference to Firestore. Then we'll write a function called fakeit, and every time this function is called, it will add a new document to the database with all of its data being completely random and fake. And lastly, we'll create an array that has the length of the number of documents that we want to create, in this case 20, and then we'll go ahead and call this function for each item in the array. Now, because this script is in the functions directory, it will automatically pick up our Firebase admin credentials. And that means we can simply go to the command line, call node, and point it to this script. And the result should be 20 new documents in your database. Now, because we've already deployed our functions, this will also result in 20 function invocations for the onCreate event. And that means if we refresh our Algolia index, we should see all of the data there as well. If for whatever reason you don't see your data in Algolia at this point, check out the Cloud Function logs to see if you have any error messages there. This would also be a good time to validate your update and delete Cloud functions. If you update some data in Firestore from the console, you should see it's reflected in Algolia after a couple of seconds. In addition, if you delete a document from Firestore, you should see that the corresponding object in Algolia is removed as well. It looks like the backend implementation for full text search is working perfectly, so we'll go ahead and move on to the front-end integration. When it comes to the front end, Algolia provides a lot of support for different frameworks, including Angular, React, Vue, iOS, and Android. I'll show you the Angular implementation details in this video, but what if you're working with a framework that's not supported, like Svelte? In that case, you can use the API client directly, or you can use the Instant Search JS library. Let's go ahead and start by looking at the Svelte implementation details because it's not framework specific and could work with any framework if you wanted to go this route. First, we'll go ahead and install Algolia Search into the app. And you could also install Instant Search at this point as well. Instant Search will give you a bunch of pre-built widgets, but in this case, I'm going to build a completely new UI from scratch. We'll go into our Svelte component, and then we'll import onMount as well as Algolia Search, and we really only need Algolia Search Lite in this case. Then we'll initialize properties for the search client as well as the index that we're referencing. Then we'll have the query that the user types into the form, and then the hits that get returned back from Algolia with the search results. From there, we initialize the search client, which is almost identical to how we did it in the Cloud function, except that we use the search API key instead of the admin API key. It's extremely important to keep your admin API key out of your front-end code because it would allow anybody to modify or completely destroy your index. From there, we'll go ahead and make a reference to the customer's index, and then we can make a search by simply calling search on that object with the query parameters that we want to pass it. In this case, we'll simply be passing the text that the user types into the form, but you could also pass additional options here to customize the behavior. Now, we want to run a query every time the user types into a form, so we'll go ahead and handle that with a function called search. It will await the results of a query, and then that result object has a hits property, which contains all of the objects from the Algolia index for that search query. So every time the hits property is updated, that will cause Svelte to react and update the state of the UI. Now moving down to the HTML, we'll go ahead and set up a text input, and then we'll bind the value of that text input to the query property on the component. Then we want to run the search on every keyup event, so we'll go ahead and say on keyup, and then have it fire the search function. And now it's just a matter of looping over the hits to display a template for each individual result. We'll set up an image with the hit avatar, and then we'll display a heading with the username, but you might also want to highlight the text that the user has typed with the results that are returned. Now, Algolia returns a highlighted result that contains the raw HTML of a property with the text highlighted. So one way to use that data is to bind it to the inner HTML of a paragraph element. By default, it will contain the text of that property, but with the highlighted part wrapped in an EM element. And you can actually customize the element used here from the Algolia dashboard. Now, to make the highlight really stand out, we'll go ahead and add a global style here for the emphasis. And you can see when we type into the form in the demo that the search results are updated and the user's keywords are highlighted in the search result. Now, this UI could obviously use a lot of work, but we now have a full stack, full text search feature in our Svelte app. That was pretty easy, but if you're using Angular, Vue, or React, it's even easier. Algolia provides a bunch of pre-built libraries and components for these frameworks. To get started with the Angular version, you'll want to follow the official setup instructions, which will have you install the package and add it to your ng module. And then I've generated a search component here in my Angular app, and you can see that it relies on zero TypeScript whatsoever. And that's because Algolia has already done that stuff for you under the hood, so you're simply working in the template to display the actual UI elements that you want to show the end user. The first thing you'll do is wrap your elements in the AIS instant search component, and that will give you the context to search a specific index. From there, you'll want to display a form input, which you can do with AIS search box. Then you can use the AIS hits component to give you the context for the hits and the actual search result object itself. Then you can use Angular directives to customize the behavior of the template. For example, we'll say no match is found when the hits length equals 0. And then we'll go ahead and use ngIf to loop over the array of hits and display a template for each result. And we can easily highlight text by using the built-in AIS highlight component. Just specify the attribute you want to highlight and then pass in the hit as an input property. And now we have full stack, full text search in Angular. So at this point, it's just a matter of making it look good with our design system. So I'm going to go ahead and wrap things up there, but keep in mind there's a lot more you can do with Algolia, like multi-property filtering, geoqueries, and things like that. If this video helped you, please like and subscribe, and consider becoming a pro member at Fireship.io to get access to even more content. Thanks for watching, and I will talk to you soon.